name is Deepak Hemani and I work in the Department of Computer Science, IIT Madras, and I am here to introduce my short course, which is a 20-hour course on constraint satisfaction problems, and I hope this will motivate you to come and register for this course. Okay. So, let me just give you a very brief introduction to CSPs or constraint satisfaction problems as we call them. These are representations where the problems are formulated as a set of constraints between a set of variables, and formally we say that it is a triple. So, x is a set of variables, d is a set of domains, one for each variable, and c is a set of constraints where each constraint is a relation over a subset of the variables essentially. So, an example should help that. Now, many problems can be posed as constraint satisfaction problems, which means that a user has to focus only on formulating the problem as a CSP, and the solving part can be handled by an off the shelf CSP solver, which is what we will try to look at in this course as to how do you develop these solvers essentially. Now, CSPs are important and interesting, particularly because they allow us to combine search and reasoning together. So, in the problem solving using search, we did only search, in knowledge representation we did only reasoning, but here we can do a combination of two. So, let us look at a couple of examples and see how that is happening. So, one example is the n queens problem, which is a well known problem, where in this instance of the problem it is a 6 queen problem. There are 6 queens you have to place on a 6 by 6 chessboard. The queens are q 1 to q 6, and the values that these variables can take are the column numbers a, b, c, d, e, f, and the constraints are that no queens can be on the same column or on the same diagonal essentially. Now, searching would simply say try queen 1 on column a, then try queen 2 on column b or something, and this kind of thing, but the moment you place queen 1 on column a, as you can see on the figure on the left hand side, you know that you can't place queen 2 on column A or B, you can only place it on column 3. So, this is some reasoning which is being combined with search, and on the right hand side figure you can see that after you have placed 4 queens, then there is no place left for queen number 6. So, you might as well backtrack from this place itself. Here is another example where constraint propagation has been used effectively. So, there are these line drawings which have to be labeled with each edge has to be labeled with one of 4 different possible labels, that whether it is convex or concave or whether it is an edge where the material is on one side. And you can see on the 2 figures that on the left hand side we have a convex filled cube in red, whereas on the right hand side we have a concave hollow cube in red. The red figures are the same, it is just that the labeling is different, and CSP allows us to handle this problem effectively. Lastly, let me introduce this thing called cryptarithmetic puzzles, where you have this puzzle which says send plus more should be equal to money, and what we mean is that if you substitute values from 0 to 9 for S, E, N, D, M, O, R, E and so on, it must work out that the arithmetic is proper essentially. So, the constraints comes from arithmetic and the fact that each letter must have a distinct value. And then we have 4 hidden variables C 1, C 2, C 3, C 4 essentially, which are the carries that you would do if you were doing addition. Now, you can see that you can immediately start some reasoning instead of just doing blind search. You can say that this most significant bit m must be 1, and because the carry can at most be 1, and this already you have part of the solution here. And then next you can reason that the next significant bit O cannot be 1 because already m is 1, and it cannot be 2 because then the carry C 3 can only be 1 and S can be at most 9. So, O must be 0, and in this fashion you can continue reasoning and combining it with search, and I will leave it for you to complete this problem and hopefully come and join this course on constraint satisfaction. Okay. Thank you very much.